All right. So we're about to get into chapter 8. Of course, we just finished chapter 7. That problem about the temperatures, right? And if you didn't take the test, don't worry. You're getting a different test. From global temperatures, it's really hard for me to hide my political ideology, but I don't give a shit. This is statistics. It's all about numbers. Numbers tell you stuff, and if you don't listen, that's up to you. But I didn't want to go on some political rant. There was a problem where it said for the last 5, 6, 7, 8 years, depending on what version of the test you had, the temperature has been this. Is that unusual? And most of you guys picked up on either you can use the problem right before that. So if, like I said, for the last 8 years it's been 14.7 degrees, and the problem right before that said the probability it's more than 14.69 degrees is basically 0%. So you just had to reference that and say, well, there you go. It's basically impossible, so if it happens, something must have changed. Okay. So some of you guys reference that. That's fine. Or you could construct what's unusual. Some of you guys, when you did that, so you all know the problem I'm talking about? The one about the temperature has been this. Is that unusual? Is that evidence something has changed? Some of you guys did the max and min usual, but you used the old standard deviation. That doesn't make any sense because we're talking about a group of so many years. You have to use the new standard deviation. That is actually feeding into what we're about to get into in chapter 8. So I'm going to come at this two different ways. Try to, anyway. So if I have a normal distribution, the mean is somewhere, right? In fact, it's in the middle of it, but if there's so let's say, do you guys know the average, do you know what the distribution of dolphin lengths are? Anybody, just randomly? I wish somebody would go. Sure do, man. I've been waiting for this question. You guys know what the distribution of dolphin lengths are? I'm not saying I do either, to be honest. Right? We don't have a flipping clue. So stay with me. Hello. Last thing you thought you'd be talking about 7 a.m. on a Wednesday morning is dolphin lengths, but we are. How could you investigate that? We don't have a clue about it, do we? We have a rough estimate. You guys have seen dolphins, right? You guys have seen dolphins? We know what a dolphin is. Okay. So, if we were able to go out in a boat, how could we determine an estimate for the average dolphin lake? What would we do?
Grab a sample.
Huh?
Grab a sample.
Okay, be just a little more specific. And what would we do? We'd go out in a boat, measure dolphins. It's crazy, right? And then we don't have to get too specific. How the shit do you get a dolphin? How do you catch it? How do you call it a dolphin? Got a minute? I don't know, right? So somehow you go out, you hopefully get people that know what the shit they're doing to help you, get some dolphins, take a sample, you measure them, and you get an average. You guys with me so far? That's what we did. Now, you guys agree that, so let's say we take a sample of 38 dolphins. We managed to get 38 dolphins to come up to our boat and get close enough and we can measure them, right? Give them some food, and they go on their way, okay? And they're actually conducting experiments on us, but it all works between the two of us. What was I about to say? Do you agree that the average we get, how do you think it should relate to this? And this, really stay with me. This is the real distribution of all groups of 38 dolphins. How do I know that that's normal? I just drew that as normal. How did I know that? How did I know that the distribution of sample means for groups of size 38 dolphins would be normal? N is greater than 30. I like it. All right, so that's just a little side note. That's why I could draw that picture. You don't want to draw that picture unless you really know it really is normal. So some of you guys have a uniform problem, you draw a little normal picture and you start making z-scores. No shit, no. They have nothing to do with uniform stuff. All right, let me come back. So we take a sample of dolphins, we get an X bar. If we took a really good random sample of dolphins, where should that be on the picture? Is it going to be the same as this? If you go out right now and you take 38 Grossmont students, will their average age be equal to the average age of all Grossmont students? What do you guys think? What would you put your money on? If you went and took 38 Grossmont students randomly, got their average age, would you put a lot of money on it being exactly the same as the average age of all Grossmont students? Hell no. Because you're college, you don't have much money, and you're going to gamble smart, hopefully. You got to pull all your money on that shit, right? Why not? A sample's mean should be close to the real mean. If I took a really good random sample of 38 dolphins, try not to leave any dolphins out, right? Then their average age should be close. But will it be equal to? No. I'm going to put a lot of money that it isn't equal to. All right, guys, this is first day stuff, right? We talked about this stuff on the first day. And you know this is true. You know when you take a sample, it's not going to equal the whole population. Of course it's not. Could it? Yes. How big is that probability? Small. You guys semi with me? All I've said so far is take 38 dolphins, average their length. It's not going to be the same as all dolphins' average length. And that's a statement I think we can all get behind. Dolphin 2020, right? All right. So, let's just say, just for the picture, we take a sample of dolphins and they end up right here. So we just happen to randomly pick some longer dolphins. Is everybody with me? It's a little bit above the real average. Now, we don't know that. All we do is we put, here's X bar. That's what we know. Really? So that picture I've drawn, we don't know it. We don't. I know that it is normal because the sample is 38. I know that, but I don't know where the mu is. All I know is frickin' X bar. That's all I got is the sample. I don't know all dolphins. I'm not like some freaky ass Professor X. I know all the lengths of dolphins. Okay, maybe. So, let's see, where should that X bar lie? Where should it lie 95% of the time? So 95% of the time it should be within roughly 2 steps. It's actually 1.96. We're going to see that later. So every time I take a sample, shouldn't most of them fit right in there? And that's why that's the tallest part. You guys with me? Somebody with me? Okay. So, how do I get this then? How do I figure out what these are? If I knew mu, what would I do to figure out what those are? So here's the idea. Let me give us some numbers. Let's say that the standard deviation of all dolphins, I got something of all dolphins here. Let me be sort of, I think I sort of looked this up a little bit, but not really. Let's say the standard deviation of dolphins is about 4 inches. Standard deviation in their lengths. Did I really say 4 inches? I really did. Right? And let's say that I want to know what are the lengths that would capture 95% of all groups of size 38. Okay, so let's piece all this together. So there's a lot of parts we've gone through that come together in this one problem. I know the basic idea. If I go out so many steps, I catch 95% of the information. We know this, right? So let's start with that problem. Let's just start there. Can you guys, I gave it away a minute ago, but let me see how many of you guys are paying attention, and maybe you can double check me. If this is 95%, what's this? 0.025. look that up real quick. Double check if you heard with the z-score I said earlier. Double check me. If you didn't hear me, look it up for yourself. What z-score does that correspond to? Huh? Or just be careful. I'm not looking up a z-score, I'm looking up an area. I want to know what the z-score is. So where are you trying to find 0.025? Trying to find it in the body. Not 0.0025. 0.025. There it is. Did you guys hear me earlier when I said 1.96 anywhere? Yeah, I'm like, dude, I listen to about every fifth word you say. All right, great. So again, another way to look at this. This is old news. I could have asked you what's P 2.5. The 2.5th percentile would be this, because it's got 2.5% below. How far below the mean do I have to go until I only have 2.5% below it? 1.96 steps down. So how far up do I go? Positive 1.96 because of symmetry, right? Okay, that step is old news. Just how far do I go to catch 95% of the data? Okay. Now, if I want to construct this, let's pretend that we're the dolphin god. All right, I love it. You guys just go with me. And I know that the average length of all dolphins is 91 inches. So that is nothing that we mere mortals could know, because I cannot go out and measure every dolphin in existence. Right? I don't care how many submarines and boats you get, you're going to miss some dolphins. I'm sorry. You guys with me? Everybody a little bit with me? A little bit? I'm sorry if you hate dolphins. It's just what I chose to talk about. Stupid little dolphins. Now, can somebody help me figure out what length this is? And at this point in the class, you have to understand what I mean. There's an average length. I'm dolphin god at the moment, so I know it's 91 inches. I know I've got to go that far below it to figure out, to have 2.5% there. What length is this? So I want to go from the mean, I want to go down 1.96 steps. So the real key here is, how big are the steps you're taking? I love you guys so much. So it's a z-score is the number of standard deviations away from the mean that a data point is. So if I know the z-score is negative 1.96, that means that it's 1.96 steps below the mean. So it's mu minus 1.96 times the step size. You want to go that many steps below the mean. That's the mu plus z sigma crazy ass little formula. You don't even need the formula, it just makes physical sense, right? Okay. Or it does. I'm not asking for agreement, I'm asking for you to realize that. Okay. Now, why can't I do this? What's wrong with this equation? Dolphin God can be wrong. What's wrong with me doing this? 91 minus 1.96 times 4. There's one thing that's wrong with that. Did I go down 1.96 of the right step size? I mean, what is it that I'm talking about? Am I talking about one dolphin? Am I talking about one dolphin? I'm talking about how many dolphins? 30 freaking 8. So what's wrong? What's wrong with 4? I should have done what to it? I should have divided 4 by
square root of 38.
Yes. Now that's the sample. Now that's the standard deviation for a sample of 38 dolphins. That's how spread out every sample of 38 dolphins is from their average. And that was like number 5, part 2 on the test. When we took a sample of years, the very first thing you should have done on that is change the standard deviation, of course. You got to make a spread for groups.
So is this defined what exactly?
All right. So if I knew that the average was 91, I want to know. So I'm Dolphin God. Humans are doing their shit. I see a lot of people going out in different boats going to get dolphins and get their sample sizes, right? Their sizes, get their sample averages. Every boat that goes out is going to get a different sample. So they're going to get a different average dolphin length. Come on. We're not doing anything crazy thing here. If I have one group go that way, one group go that way, one group go that way, they get their own samples of dolphins. Are they all going to be the same? No. So Dolphin God, he ain't got much to do all day. He's freaking dolphin. I don't know what the hell Dolphin God. He wants to know between what two lengths would 95% of the people going out in boats find? So shouldn't everybody that goes out in a boat, if they take 38 randomly selected dolphins, shouldn't their average length they find be close? More likely they'll be close to the real average. Is everybody cool with what I just said? Okay. Is it possible they could be farther away? Yes. You could randomly happen to get a bunch of really long-ass dolphins somewhere or short little stubby dolphins. You don't know. You guys with me? No? Okay. All right. I'm just going to keep going. So, I just want to know 95% of the time, the lengths that they find should be between this length and that length. That's all I want to know. Just like the temperature problem. If about 95% of the time the temperatures for a group of whatever years are between this and this, and I see a group that's here, that is evidence that something has changed. Not a damn political thing about that. It's just a statement of fact. And the political shit comes later, right? The dolphin thing, though, it's a little less controversial. Right? Does everybody get that? No? So, if I had 100 boats go out and they all collect their own samples, 95% of them should find an average length between something and something. It should be really unlikely that some boat finds really long-ass dolphins or really short-ass dolphins, right? Nothing against either one of those groups. So all I'm doing right now is, I know theoretically I should go down 1.96 steps to see what the smallest dolphin length I should see is. This is roughly equivalent to unusual, right? If I go 2 steps down, that's roughly 2, and I go 2 steps up, anything outside of that should be unusual. So that's all I'm asking. Where should they usually find dolphin lengths? So if a group goes to a certain island and gets some dolphins there, and they get a length here, is that possibly evidence that there's something interesting about that location? Some food they're eating is just making them grow really big. You guys with me? Do you guys understand? So if I go out and I investigate the number of cancer occurrences somewhere and it goes in that location, that might be evidence that something is happening there. Maybe the water's been tainted, the air's bad, whatever. Same idea. Okay. So what would this be? It's whatever the shit that is, right? And then if I want the other one, I just go up. All right, now, the next step to this is to remember, this is all from the perspective of who? Dolphin God, right? I don't know what you guys think about that. I think it's funny as hell, but Dolphin God. So I'm not dolphin guy. So let's come back to reality. I don't know that shit. I don't know 91. I don't know. Right? I don't know this picture. I don't know where that is. Okay, now here's the step that I really want you guys to be with me. You guys agree 95% of the time when I get a sample mean, it should fall in there, right? But so what is it in reality? In reality, we don't know what that is. In reality, I can't do this shit because I don't know what that is. So what we do instead is we make, instead of making an interval around this, we make an interval around this. So, this is coming from this guy here, right? Yeah. This little formula, that's basically what this is. It's just the first tweak we did to it was we did this. Right? Isn't that what we just did? Why did this have to be here? Because now we're talking about sample means. Now here's the next tweak. We normally don't know this shit, do we? What's our best guess for this? So if I go out and I take a sample of dolphins and I get 92.6 inches. What's my best guess for what the real mean is? I ain't dolphin god. Dolphin god? That's awesome. I ain't dolphin god. Right? I don't know what the actual average length of dolphins is. All I know is this. So what's my best guess for what the real average length of all dolphins is? 92.6. That's the only shit I know. And if I took a really good random selection of dolphins, I should feel pretty good about that guess. So what we do is, I'm going to take this picture away. What we do, this would be the ultimate. If I was freaking some kind of deity, whatever your favorite deity is, I would do this. I could do this. We don't know that shit because we're just poor little humans, so we use that. So instead of knowing where this is and asking where most of these should fall, what we do is I go take a sample, I make an interval around it. Does everybody see that? Because plus and minus, so I make an interval around it. And let's say that it's 95%. So I'm going to put a 1.96 here, right? Because we already figured that out. That's the z-score that corresponds to 95%. That means that there's a 95% chance that my interval contains the real mean. So what we do, so what kind of sucks about statistics in general? The reason people kind of say it sucks is because we never know the real answer. But that's why I love statistics. It is the most real life math. It says, you never freaking know. So give or take something, I don't know. So when we go take a sample, we get an average. I'll put money that's not the real average. This process makes it a little better. It says, all right, you got a number, so we're going to say there's a 95% chance that the interval you create catches the real mean if you go up and down 1.96 steps. So it gives us a better, instead of just one number, if I told you the average grade in the class was 80, how do you feel about that? That sounds really good, right? But what if I tell you the range goes from 58 to 102 versus the range goes from 78 to 82? You guys with me? Knowing that extra step, okay, not just one number, but give me an idea between what two numbers should the real mean fall, possibly. All right? So this is what's called, so if I construct this, how confident am I that I catch the real mean? I would have to be how confident? 95% confident. So we call these confidence intervals.
Confident what?
Confidence intervals. Is everybody with me that that's an interval? And it's an interval that represents a certain level of confidence that'll actually catch something. Okay. So, let's do a problem. So I'm going to put this up here. Again. Yeah, okay. That's a confidence interval. So they ask you to construct a confidence interval. That's the formula you're going to use. There are going to be 3 of these we learn. 2 for the means and 1 for a percentage. Is anybody paying any attention to, there's this thing that's going to happen, an election, right? And there's like way too many people right now debating on stage about becoming a Democratic candidate. Is anybody paying any attention to that at all? Some of you guys trying not to, but you can't escape it, or some of you guys really paying any attention? Anybody? I think a few of you guys. Do they have polls that they take? Yes? So they do a poll about, what if it was Biden? Will he beat Trump? Or whatever. And there's also a poll about, do you want Trump impeached? And whatever. If I told you 51% of people want Trump impeached, that's not enough information. If I tell you I'm 95% sure that between 48 and 53%, you would find the real percentage of people that want to, okay, that's more information. That tells me a little bit more. So, for example, if I said somewhere between 48 and 53% want Trump impeached, versus somewhere between 30 and 70% want Trump impeached, which one has more uncertainty in it? The 30 to 70 is like, holy, it's like you basically are saying you don't know. So why did you open your mouth, right? So we construct confidence intervals to communicate not just what we found as an average, because you can always find the middle, but also how sure we are about what we see. We incorporate the standard deviation in that business. All right, so if I took a sample of, let's do something a little less freaky. If I took a sample of, what you got, Jeff? 82 students, and find an average number of hours studied a week is 7.2 hours. Yes?
Sorry to backtrack a little bit, but you said that there's going to be 2 for means and then the other one is...
For percentages. So the thing about the election stuff, isn't that all about percentages?
Yeah.
40% want to vote for this guy and 42% want to vote for that one, right? So we have to have we're finally going to learn where the plus or minus 4% that shows up at the bottom of those things, where the shit that comes from. We're going to be able to calculate that stuff. And I know some of you guys are like, I didn't need to. Too bad. You're going to learn how to. And hopefully some of you guys are like, yeah, I want to see that shit. Where do they come up with that? They just go, I don't know, give or take 4. No, it comes from somewhere. So far, nothing big here, right? Took a sample of 82 students. We found that they study on average 7.2 hours a week. This is the part that's a little bit freaky, but sometimes we do know the population standard deviation. Let's say that we know the population standard deviation of hours studied is 1.9 hours. So the other formula for means is going to be when we finally fully go real and say, okay, we normally don't know mu, but we normally don't know sigma either. But right now, we do sometimes know sigma, so this is why we're starting here, the easy part, and then it's going to get a little freaky for the other one. All right. So up here, everybody cool with this? We knew going in, standard deviation for all students everywhere is 1.9 hours. I took a sample of Grossman students and found that they studied 7.2 hours, right? How do I know this is normal enough to continue? Yeah, so n is 82 greater than 30. I can do something. Our central limit theorem says, okay, you can go for it, it's normal enough. So let's say I want to construct today's not a good writing. No day is a good writing day for you, John. Let's make a 90% confidence interval just to change it up a little bit. For the true mean time spent studying. So just to make sure you guys are kind of on board, that's the sample mean. I would put a lot of money that that mean is not the real average time spent studying. Are you guys with me? Because that's only 82 students. How many students go here? 17, 18,000. Somewhere in there. Used to be 20,000, but oh well. We only have 18,000. That's plenty. That's plenty. Some more spots maybe. What do I know for this formula right now? So this is the formula we're going to use right here to construct the confidence interval. I don't have 3 to choose from, so that's easy. I'm just going to choose that one. So if I say make a confidence interval, you're probably going to choose one of the 3 equations that has a plus or minus in it, because that's how you make an interval. Holy shit. Okay, I like it. So, what do I know? What did I tell you in the problem that you need for the formula? Did I tell you this? Yes. Did I tell you this? Did I tell you this? So what's the only thing I don't know yet? Yeah. And how do I get that? What's the piece of information that leads to that? 90%. Can you draw the picture? Since n is greater than 30, what's the picture look like? Normal. I love it.
What does n say? N equal
The sample size.
82, which is bigger than 30, right? Central limit theorem says go for it.
Thank you.
So the step that I couldn't do if I didn't have that is the step we're about to make. So what's in here?
90.
90%. So what's out here?
0.5.
0.05. Can somebody look that z-score up for me? This is going to be one of those asterisk ones. You're going to learn these z-scores without even trying because they're going to be in every freaking problem.
Oh,
Mm-hmm. Let me stop for a second, you guys.